by using this front end, you can also move away from using a resonant converter for your DC to DC converter. You can go to using things like flyback converters, which are making a big resurgence.
Cool. So it's Eamon with IP Exchange. We're on the Newcomer Pavilion at PCIM. I'm talking with Zaki from Pulsiv.
Yes, that's right.
Looks very interesting. So, Zaki, would you like to tell me a bit more about what Pulsiv do?
Yeah, certainly. Pulsiv has developed a new technology to improve efficiencies, especially at low power modes for power supplies. So this is applicable to any power supply over 70 watts. And with the new USB-C standard becoming ubiquitous and trying to get everything to run off USB-C, it's the right technology coming at the right time.
Cool. So your colleague, was it Nick?
Nick, yes.
He was telling us about how you have power supplies and they'll run at a certain efficiency, but then when they go into a lower power mode, that's actually the least efficient operations.
I don't know about you guys, but every time I use my laptop, I leave the power cable plugged in.
Yeah, same.
And even though the battery is at 100%, it's still plugged in. And if I touch the power supply, it's warm because it's losing a lot of power, even though it's not using very much.
Yeah.
So about half the power that I'm actually using is actually being lost within the power supply because the power supply is very inefficient at very low power levels. So the technology that we have changes the way the front end of the power supply works, and that is the key element that loses a lot of energy in low power mode, and this is what we are showcasing over here. So just to give you an idea of what we do, we've come up with a development system which you can see over here. The Pulsiv technology is actually programmed inside a small microcontroller, so that 4mm by 4mm square it holds our technology, and what that does is it regulates the interaction between the grid and a storage capacitor.
Cool.
And what that enables you to do, so capacitors are the key because they store energy in a very, very efficient manner. Conventional systems have an inductor as their front end, and if you design an inductor for like 100 watts, if you then use it at 10 watts or at 5 watts, it's very inefficient because it wasn't designed for 5 or 10 watts. Whereas the capacitor is a much more efficient way of storing energy. And this is really the key to improving the efficiency at the lower power end. So by definition, this is much more efficient than using an inductor.
Cool, excellent. So I guess this will be, we spoke to some other companies earlier on about moving to that USB-C standard. So this is going to be absolutely fantastic for that.
That is the area that we are targeting, because by using this front end, you can also move away from using a resonant converter for your DC to DC converter. You can go to using things like flyback converters, which are making a big resurgence. The most important thing of flyback over a resonant converter is it's cheaper. So it's cheaper, it can respond to dynamic loads a lot better than resonant technologies. And it works perfectly with our front end. So we are looking at coupling our front end with flyback converters to producing very efficient and very reliable power supplies that not only have excellent efficiency at the high power end, where you spend a very short time, but also at the low power end, where unfortunately you spend the majority of your time, just because of the nature of the way USB-C is used. You leave things plugged into it all the time, and that unfortunately means you're always running in low power mode for the majority of the time.
Cool. So I guess it won't just be it wouldn't just be better efficiency, it would be saving you cost overall as well, both on the energy and in the cost of say, using that flyback topology.
Exactly,
So,
exactly. And you use it's greener as well because it doesn't require as much material as a resonant converter. So there are many positives in using or migrating away from resonant type technologies back to flybacks.
Cool.
Yeah, from many perspectives. So yeah, very very excited to be here because I think this will be essential um, in in. In bringing in this new USB-C revolution, which I support so much. I'm sick and tired of having so many different cables
Yeah.
for every single thing, and just moving to just one cable, I think is essential.
Excellent. So just to clarify, if a design engineer was looking to evaluate your technology, is that what they would be going for?
So we have produced this just to support design engineers to investigate our technology, but we're also bringing out a 150 watt reference design.
Oh, excellent.
So 150 watts, it's a lot easier if you start with a larger power level and then scale it down. So you should be able to scale 150 watt power supply down to 140 or 100 watts, which are the larger levels for USB-C, as well as 65 watts, which is another popular USB-C level. But I suspect most of your listeners would, if they think they need a 65 watt, they'll probably want 100 watt or 140. Everybody wants more power.
Yeah. So speaking of more power, what would you say is what kind of target applications are you looking at? I've heard Nick say some stuff about the consumer market.
The target this has application in a lot of consumer type products because of what it is. At this point, we're being strategic by deciding what we are not doing rather than what we are. So we're focusing on the USB-C initially, just because it gives us something to target. And it's better to be targeted at this stage. And the USB-C market as well is a very, very large market. So we believe there's enough room in that space for everyone.
Cool. So if you're going for USB-C, look no further. So that was the first of our interviews from the Newcomer Pavilion with Pulsiv. Possibly the most intriguing technology we saw at the show to do with power devices. I highly, highly recommend checking them out. It really is a game changer. So learn more about it on the IP Exchange website. And if no one's interested, then something's wrong.